I want to be able to see the slides, so I'll be roving a little bit here. Again, Curt Newton, Director of MIT OpenCourseWare. I want to start by, just for a few minutes, setting the context about what OpenCourseWare is and the state we're in right now before we jump into some details about this specific exploration that we've been engaged in around the MirrorSite program. Next slide, please.
You have to click on the poison.
Big green button. Boom. Okay, thanks. So, OpenCourseWare is in its third decade, sharing knowledge from the MIT curriculum freely with the world. We estimate we've reached over 500 million people around the world. It's 500 million people with this knowledge. What is OpenCourseWare more tangibly? We have published on our live site currently about 2,500 courses reflected in various ways. That's from all departments on the campus, ranging from the most introductory undergraduate to some of the most advanced graduate level seminars offered anywhere in the world. Faculty contributes their material to us voluntarily. We say, you've done basically the work in creating the materials for your class. All we ask that you share it with the OCW team for us to produce it. That production model, I realize in listening to the last talk, is actually it's a form of sort of centralized production that we put in place over 20 years ago because we were trying to prove the validity of this model to the world. And so we didn't want to figure out how to train all of these faculty how to create the materials with license clearance and so forth and formatting. At that time, we created a team to sort of centralize the production of this stuff from whatever the raw material was. And with a great deal of care and frankly, a lot of time and effort going into it, putting these things online. When you go onto the OCW website, what you'll see is a lot of teaching materials in various forms, lecture notes, syllabi, assignments, project descriptions. But more than that, we have always also shared student contributions to their learning. Nowadays, this goes by the term open pedagogy, when students are sharing their materials into the open commons. But you'll see tons of, for instance, student work on essays and some end of semester projects, which really enriches the materials. And increasingly, we're sharing a lot of video. When we started, video was considered to be too expensive to produce. Nowadays, we're running at, I'd say roughly around 20% of our publications have a substantial amount of video, and that's wonderful. Lastly, we're adding not just the what was taught in the form of these materials, but how it's taught through interviewing faculty, what we call instructor insights. Kind of the pedagogical perspectives of faculty is increasingly woven in there. Our users, when we originally started, it was expected, who's going to use this stuff? It's going to be mostly faculty. The growth of curious, independent learners caught everybody by surprise. And we estimate roughly half of our user base are people who are not exercising any sort of institutional affiliation. They're not enrolled somewhere. They're not an instructor. They're just curious people. The other half are. And so it's really interesting and I think a unique position for MIT OpenCourseWare to try to serve these two, in some ways, quite distinct use cases from a single solution. Our new platform released a couple years ago is now much more mobile responsive, and we're seeing the growth of people now increasingly using OCW materials on their phones. It's about 2/3 laptop, 1/3 mobile, and we grew the mobile percentage over 5% last year, so it's gradually increasing. The spirit here is making sure that we're getting the material to the learners wherever they are. And that's part of the spirit for this MirrorSite program as well. While the website is the sort of heart and center of what we do on OCW, we're also doing a lot of things to make sure that content gets out in the world in effective ways. So we allow our content to be deep indexed by search engines. We've got all our videos on YouTube, because that's where the learners are, quite frankly. We've got the largest subscriber base of any .edu in the world. We're coming up on 5 million now. Our content, because it's Creative Commons licensed, we encourage people to download, remix, and reuse it, create adaptations. For instance, our colleagues at the organization LibreText have taken about 30 of our rich lecture note sets and turned those into things that look a lot more like an online textbook, which we think is a marvelous thing to see. And they're also experimenting with automated language translations, another form of adaptation that's enabled by Creative Commons. And that's great as well. On the bottom are the Mirror Drive and the easy course downloads. These are ways that we recognize that not everybody's got, reliable, high-speed internet connectivity all the time. So it's really important, especially when we think about supporting users around the world in all settings, that people can access and use our materials when they're offline or when they have spotty, unreliable internet access. About 2/3 of our traffic to the website comes from outside North America. And you will see, the numbers, the numbers show up there. Especially in the global South, Africa, Latin America, and some places in Southeast Asia, relatively few people are getting there, in part because of challenges with the digital divide and lack of connectivity. So we have this mirror site program where all OCW content, I think it's about 2 terabytes of content overall, gets put on a hard drive and shipped out to people. And that has allowed us to expand our reach out in the world in, I think, really important ways. I'm glad that Sharon Lynn, my colleague, who is the sort of on-the-ground manager of the Mirror Site program, has just joined us here. We have this agreement. It's an informal agreement. It's kind of a handshake that anybody who requests one of these mirror drives says that, we're a nonprofit educational mission entity. We'd be happy to have your OCW content put on our local network in whatever form it is and make it available to people in those contexts. A couple of examples of where these things have gone. I'm probably not going to pronounce this right, Itakato, a nonprofit in Myanmar, which sets up these e-learning hubs at schools and at libraries, and has reached many thousands of people in their communities through having the OCW Mirror drives installed in these locations. And these are individual learners as well as the educators that support them. Another case, there's these national research and educational networks together, right? NRENs that are springing up around the world. One in Africa with an instantiation in Somalia has got OCW Mirror drives available for its community. And again, these are primarily serving universities and schools who might be plugged into these things. But this has been a force for expanding our reach into, in particular, the global South. So to date, again, we've got on the order of 440 plus of these things shipped out in the world. You can see on the left, the majority of them are in Africa, with Asia and the Middle East, having the second, largest number of drives out there. Some of the challenges that we face with this, frankly, 20th century solution, the physical delivery of the drives. Sometimes it's not easy to get the drives there. FedEx doesn't always get to the places we need it to, so often it's human couriers that are taking these things out for us. The OCW website, as was rebuilt a couple of years ago, does not integrate within it in an online sense effective content discovery. We're relying on online web servers for that, and we've realized in trying to rebuild the mirror drives for our new structure, there's some challenges around discovery with these drives, and so that's a thing that we're working on. Content updates. We rely on the end user to manually go out over currently Amazon Web Services and run a sync process to get the latest content. There's a lot of mirror drives out there that we know are not showing the latest stuff, and that's unfortunate, but it's kind of the nature of the environment we're working in. Lastly, and increasingly so, what we publish on OCW is making use of other online resources. There's a lot of externally linked public-facing information that the OCW team is no longer centralizing onto our servers. We don't have the time, the capacity to do that work. We're just pointing people out to it. But when it comes to people who are working in an offline context, unfortunately, they're not going to get that stuff on the mirror drives as currently fashioned. So there's a big opportunity, I think, to shore things up for these externally linked resources. So with that, Ian, we have been, kicked off early some experiments with how the IPFS network and some of the technology you're working with might improve this effort to get content out to people who don't have reliable connectivity. So,
got some slides. Can you go forward? Awesome. So I'm Ian Davis. I'm a partner social impact engineer with the Filecoin Foundation for the Decentralized Web and the Filecoin Foundation. I work with a lot of our partners in this room on a variety of technical research initiatives. In this case, we'll be talking about the OCW Mirror program. So first off, I'm just going to start with a brief intro to decentralized storage. I know a lot of people already know how it works, but I'm going to run through this pretty quickly. But just in case you don't, here's the basics. The decentralized web is an alternative network infrastructure. Instead of going to centralized servers to fetch content, it's a peer-to-peer network. You ask any node in the network for a particular identifier. The network itself discovers, finds a particular piece of content, and then delivers it to your node, and then eventually to you. And how these content identifiers work is it takes a piece of content like a cat picture, or in the case of MIT, an OCW course folder, which includes lots of videos, lecture notes, everything. And it generates a content identifier hash, which is unique to that piece of content. If anything in it changes, that content identifier is going to change. This gives the network a level of verifiability to make sure that content isn't being tampered with. It also, as I'll talk about earlier, makes it really easy to do diffs. To figure out what has changed in a long list of courses and what courses might need to be updated if there are changes upstream. The nodes gossip. It's called the gossip protocol. They talk to each other about who is storing what. So whenever you ask the network for a particular piece of content, they bounce around, talk to each other. They're like, I don't have it, but I think this node over here might have it. You should go ask them for the piece of content. And then once you do, you make a direct connection to that node. You fetch the content. And you're off to the races. Filecoin takes this decentralized network of IPFS and adds a storage on-chain incentive mechanism. This does require the nodes to be in communication with the network as a whole. Not all of the mirrors we're talking about in low connectivity regions are going to be Filecoin nodes. They're probably going to be IPFS nodes. But Filecoin nodes can be located anywhere in the world, and so these Filecoin nodes can serve as local archives that an institution nearby could potentially get a copy of the Mirror program from in the first place, and then run their local IPFS node that's redistributing it in an area of low connectivity. So now I'm going to go into sort of open education more specifically and talk about some of the applications and ideas we've been discussing with MIT about how this technology can be used. So the benefits of some local mirror nodes on IPFS. The local mirrors, as Curt mentioned, are designed so that they can be accessed locally, even if they can't reach MIT or AWS servers. A lot of the content is available on S3 right now. It's also available through MIT's site. The IPFS, if a local mirror were run using IPFS, the content would be more trustworthy in the sense that anyone could verify that some local professor hadn't gone in and changed a bunch of the educational information, which in the case of science and technology lectures, maybe not that important. In the case of humanities, human rights lectures, probably a lot more important. This also means that you don't even need a local institution to be running the node. Any private individual who has the ability to run an IPFS node could run a trustworthy node, because the content identifiers are going to uniquely identify each of the courses and each of the individual pieces of content within a course by a particular identifier. One of the things Curt and I also talked about is that large institutions like MIT have the resources to keep these archives, but smaller institutions like state schools, community colleges, other local institutions around the world don't necessarily have those resources. And if we want to build a system where MIT isn't the only open education provider, building on this shared infrastructure allows a lot of these other institutions to participate in the process without, even if they don't have the sort of resources of MIT. And then, the last thing is that because of the network of decentralized nodes, IPFS resists local censorship. So if you have a couple of nodes in a region that are all replicating this content, even if one of those nodes potentially gets blocked, even if MIT's site gets blocked in a particular region, these local nodes are going to route around that disruption and allow you to still fetch any content that a local centralized authority is trying to censor. And so this is a map of Filecoin storage providers right now. And when I was in college, I also studied sort of sustainable development around the world, specifically when it comes to ICT, internet technologies. And one of the things that I really loved was institutions in the West or in the North, global North, would put a bunch of effort into building these technological systems and then provide basically an open source business model for local entrepreneurs to take those technologies and build a business, and off the back of that business, increase local technical literacy in a particular area. And that's one of the things that I find most exciting about the idea of Filecoin storage providers for specifically the problem of low technology regions is these Filecoin storage providers do require connectivity, they do require hardware, but once you have somebody building a business hosting content in a particular area, that's going to cause them to build out data centers, that's going to cause them to increase the overall technical capability of that region and hopefully help close that digital divide a bit. So right now we have a very simple demo mirror that we've set up on IPFS. It just includes an initial 10 courses, about 17 gigabytes of content. You can access it by going to our, there's a QR code there. We set up a URL, OCW demo at ffdw.org. But at the bottom there is the CID, and you can actually request that CID from any IPFS node. You can go to any other IPFS mirror like ipfs.io or dweb.link, use that CID to fetch the content. Our IPFS gateway, I've specifically pinned all 17 gigabytes of this content, so it's going to be much faster to load the content because it doesn't have to go bounce around to all of the other nodes asking where it is. But any IPFS node should be able to get the content based on that content identifier at the bottom. So what are some of the next steps to explore? Because obviously that's very simple prototype. We've got 10 courses and all of the associated content on IPFS. But there were a lot of questions that Curt raised that we're still interested in finding solutions for. The first is decentralized local search. So right now, as Curt mentioned, the search for material on the OpenCourseWare catalog is centralized through a web service. You can only get it by accessing the MIT site. So how can we build search that can run locally in all these regions against all of the local content effectively so that people can still find content even if they can't contact MIT? Next is performance benchmarks. Is this actually going to be a better system in low connectivity regions? IPFS and gossip protocols can generate a lot of network traffic. Is there do we need to set up firewalls in a specific way so that it doesn't overload local servers? How do we structure and test whether the system is actually better in some ways than the current approach. And then the last one is web archiving. As Curt mentioned, some of the linked resources from a lot of these courses are external websites. And one of our other project partners at Harvard has been working on web archiving because a lot of those links go away. So whether they're disappearing or whether they're just not accessible in the regions that are running these local mirrors, we want to make sure that those resources that professors think are important enough to include in their course are available to the people who are partaking of that course. And the last idea is something that Curt and I discussed briefly in our call when we were preparing for this, is the idea of diamond open education. So the diamond open access movement has been focused on open access to scientific literature and data sets and published research. But the same principles and the same ideas can be applied to open education. How do we build a system that is subsidized so that it's both free for educators to publish and free for students to consume? How do we make sure that those authors retain copyright over that content without giving it up? And how do we make sure that if there isn't an MIT name next to a course, that somebody can still trust that this is high quality education content. There are other professors around the world who have reviewed it, who think that it's a good course. This is kind of the vision that I'm really excited about, and that I'm interested in figuring out how we can support using these decentralized technologies. Because decentralizing MIT's catalog is the first step, but there are lots of other institutions around the world, there are lots of other educators around the world. How can we create a system where they can all collaborate together in an effective and open way? And that's the end of my talk. Curt and I intentionally kind of made this quick because this is a salon and we wanted to hear from all of you. So.
Is through Filecoin, with your idea of local entrepreneurs and giving them incentives, is Filecoin the way to incentivize them? Is there a way, and is it the way to say, please cache this MIT OpenCourseWare through your local Filecoin storage provider that you're running? Or is a more traditional model of like sub-grants to local organizations through MIT to just pay them to run IPFS nodes a more realistic model? Like, I'm always still, I ask myself all the time, like, should I be running a Filecoin storage nodes to make money on the side? And I don't know if that's like a realistic thing or not. And when you talked about the entrepreneurial model, I was like, oh, that's how Filecoin could be used. But I don't know if it in this scenario is the most logical approach.
I think it depends on what kind of node you're talking about. So for like a cached hot copy, it's probably better to, through subsidies, encourage people to run IPFS nodes. Filecoin is right now best at sort of long-term archival storage. But I think for the long tail of educational content is where we're seeing the most value for things like Filecoin, where, you have maybe 10 or 100 courses that are accessed all of the time that people are really, really happy of. You want those to be immediately accessible. You want to encourage and incentivize people to run those as IPFS nodes so that they're easily available. But, MIT has 2,500 courses. Once we start opening up this system to other education providers, there might be thousands, tens of thousands of courses, and not all of them are necessarily needed to be accessed immediately. You might want to be able to go fetch, every single year of structure and interpretation of computer programs to see how the teaching of that has changed over time. And that's going to be something that like a researcher is probably going to want to do. Isn't necessarily the best case for the mirror program specifically. So I think when I think about the mirror program, I think mostly about, local entrepreneurs with IPFS nodes rather than Filecoin nodes. But I do think that there is a case for geographically distributed cold storage archives for some of the long tail of education content.
If I might add, this brings to mind for me the work of the the project Colibri, which runs out of the Learning Equality nonprofit, and the investment they've been making for many years to kind of build a technology, but also the social infrastructure about having, this extensive network of locally grounded people who are running effectively, nodes that are hosting, digital learning content for that particular community drawn from a bigger pool. And it occurs to me that there might be something to explore there with the sort of social leadership, entrepreneurial social leadership that they've been running. Have you had any contact with that org?
I haven't, but Danny was nodding his head. Maybe Danny has.
Because I know it means hummingbird. So I was like, oh,
Yeah.
my Wi-Fi network is called Colibri. But no, I haven't. No, so like I think, I mean, to pick on what Nathan was saying, I think the incentive systems are really not hard, but like you have to work out how they map, right? Like one of the positive sides, I think, of the big crypto boom was just injecting that idea that there might be ways of incentivizing smaller systems. And one of the biggest challenges with it is, well, if you make those incentives financial, do they push out other systems? Do they cause people to try and like scam and so forth? I think what I'm seeing in this space right now is a lot subtler graduation between those things. So Filecoin nodes are pretty much a commercial project. You probably don't want to do those on the side of another thing. But things that have come out of that are things like there's a project called Saturn, which is more about, okay, I have more what people think about this sort of stuff initially, which is like, I have a computer at home, maybe I could distribute to my local community. And that's a much smaller scale thing. And so I think now we're getting out of these extremes. So that's a positive side, and that's something where we can attach them.
Hi, I'm Peter Kaufman from MIT Open Learning. Amazon has like advertisements during the Super Bowl and, AWS and stuff and the World Cup. And I'm wondering about the marketing challenge of convincing people that this is an alternative that is there. I've been trained by my boss in resource development, whom you'll meet later today, to lie dormant until the word money is mentioned, and then I wake up like a robot. And Danny didn't mention that word among his catalog of other words, but like it's a money challenge, or not. Maybe it's a challenge among knowledge institutions to all band together and kind of promote this alternative in a way, given the media that they have at their disposal. But I just wonder what you are beginning to sense in terms of how to tackle that challenge, if you view it as a worthwhile challenge at all.
Yeah. I mean, I'm not a money and marketing guy. I'm an engineer. But I do think about this a lot too. I think that so far we've seen the most interest and traction from people who are really interested in the ideological mission. And that gives a certain marketing benefit. People who are excited about building a decentralized alternative are excited about using these technologies in a way that they're, a little hesitant to use AWS right now. I think it's a question of movement building, right? Movements have been trying to fight against entrenched centralized powers for ages. And those entrenched centralized powers are always going to have more resources, are always going to have more money. That doesn't mean the movements can't succeed. That doesn't mean that you can't find ways to promote and get the word out about these alternatives. I do think that one of the shifts I'm hoping to see soon is, like you said, more buy-in from institutions. Like if we can get if we can convince, large academic institutions that running a series of IPFS nodes in these institutions to share and collaborate on, one of our other partners at the University of Maryland works with large geospatial data sets. And the geospatial data sets are huge, like cover the whole world. They're each giant. No one institution can really effectively host all of those, but a network of institutions could each host a bunch of the geospatial data sets that are local to their particular region, and a collaboration between institutions could host all of it without having to pay the large fees that Amazon would require to geolocate petabytes of geospatial data. So I do think institutional or enterprise adoption is required to get to the next level of adoption with this. And academic institutions seem like the most, ideologically inclined to support a system like this. The commercial enterprises are usually focused on exclusively the bottom line. And until the technology becomes cheaper than AWS for them, they're probably going to stick with AWS. It's not quite cheaper than AWS yet, but we're getting there. And I think that as we see larger adoption by ideologically aligned institutions, that's going to drive the cost down, because open source software inherently has, scale effects that I think centralized solutions don't often, because, lots of people from lots of different organizations can contribute to the same shared underlying system.
Yeah, if I might throw in another thought, more specifically about open education. MIT OpenCourseWare is probably the largest single institution repository of that content. But in the broader open education landscape, where there are hundreds of institutions that have been creating these sorts of materials, there are at least a couple of big referatory systems, OER Commons and Merlot, which people around the world use to point them and help them discover those materials. I mean, discovery is a huge problem for this stuff. And it occurs to me there might be something to explore beyond just the OCW repository, the benefits of getting it out in the network, to use some of these other, broader collective referatories for open education, to see if we can use that to get open education materials more widely out into this sort of network. Yeah.
Hey, my name's Carrie. I work in the Department of Open Learning. I'm an engineer. I work a lot on the OCW project, actually. So something I was wondering, when it comes to running IPFS nodes, it sounds like more nodes is more better, right? As far as providing access. So Danny was talking earlier about the Twitter exodus and the rise of Mastodon. And I remember seeing something that people were talking about during that time, that a lot of people were trying to spin up their own Mastodon nodes, right? And there was a question of the legality surrounding it, right? Because when you run a Mastodon node, people create accounts and create content on it. So I was reading that you need to be a registered LLC, at least in some places, to run your own Mastodon node, where people can log in, create content that other people can download. Are there any legalities surrounding hosting your own IPFS node and providing content to people? Like in the case of OCW, it's open content. Anybody can download it. It's expressly stated that you can. But are there any concerns with running an IPFS node where if people can log in, create, upload content, are there legalities surrounding hosting that node and providing that content?
Yeah, so, like any content hosting system, people can always upload content that probably shouldn't be redistributed. But the IPFS network as a whole has done a lot of work so far, and actually works with Murmuration Labs, who did trust and safety for Twitter for a long time, to design a system so that when these requests come in, they get put on a composable series of what we call bad bits lists. And then those get redistributed to all node providers. Any node provider who wants to implement that content filtration can. It's a decentralized network, so it's up to the individual node providers to do that. But most node providers don't want to redistribute bad content, and we have a team at Protocol Labs who does network analysis, who's currently doing a lot of work to identify, are there people who aren't respecting the bad bits lists, and how do we want to potentially sanction those nodes, or identify them in some other way.
Hi, I'm Clayton Hainsworth. I'm the director of MIT Video Productions. I was just curious to hear, as this project is starting with OCW, and again, you're looking at sort of 10 courses at the moment, which is relatively small for the entire catalog. How you think about success, particularly as looking at the map and seeing that there's a fairly small footprint of IPFS in Africa, in South America. In having the goal be reaching those last mile places that are difficult to get to, how you think about success, and have you thought about defining the metrics of what that looks like?
It's a good question, Clayton. Thank you. I think thus far we've just been focused on just trying to get this, prototype demo up and moving. I would look for success, in terms of progress on some of the challenges that I listed around the current mirror site program, that we've got people who are making use of this sort of infrastructure need to make use of it, getting access to the latest, versions, that the content is updated, and it's discoverable in a more functional way. I would be thrilled to see big progress on those points to get started. And then I'm sure once we get there, all kinds of other things would occur to us.
So that graph, or the map that I showed, was Filecoin storage nodes. I think there's probably a lot more IPFS nodes running in the world right now. There's probably a map of that somewhere that I could look up and share. I think right now, last time I looked, the number of IPFS nodes was like 5 to 10 times as much as the number of Filecoin nodes. I think, for me, the place where I think that IPFS could maybe help the most is on updating. So how many of the local mirrors are on the most recent version of the educational content? And can we do incremental updates with something like IPFS without overloading, their bandwidth, their costs? On top of that, can we either reduce the costs of running a local mirror, or potentially increase the revenue if they are getting revenue from hosting a local mirror? And then I think, some of the other questions that Curt mentioned, which aren't necessarily IPFS specific, but, can we increase the number of sites that are included in these archives via web archiving? Can we improve the search so that you can, discover courses that you might already have on your local mirror, or potentially even discover courses that aren't on your local mirror yet that you might want to pull in? And then sort of the very long tail, which is, I think a couple of years down the line, is can we expand it to include other institutions? And, how do we collaborate on hosting these archives